Adult Solutions. Add-on desired.
Welcome to Adult Solution. This is Kranti Kumar, Department of Physical Science. Today I am here with a new chapter, that is atoms and molecules. Okay, so this is the chapter which will in 9th standard, and some of the topic is in 10th standard for AP students. Okay, so atoms and molecules, combining with the reactions, certain chemical reactions are there in this chapter, which is for Telangana students, and for Andhra students atoms and molecules. Okay, so the chemical reactions will come in 10th standard for AP students. Okay, so let me start the lesson. In the last we studied about is matter around us pure. So in that chapter we studied what about a mixture, what is a mixture, what is meant by mixture, what are the substances which can be added to form a solution, how we are going to separating the substances which are added in the solutions. Okay, so preparation of solutions also we discussed, like saturated solution, unsaturated solution and supersaturated solution, how we can make saturated, unsaturated and supersaturated solutions, and how we are going to separate substances in immiscible liquids, miscible liquids, isn't it? We have different techniques to separate the substances which are present in solutions. So in that we studied sublimation, evaporation, even those process also we discussed in is matter around us pure in that chapter. So this is the next chapter after that is matter around us pure. So certain things will be there which related to that chapter, and new one also present in this chapter. So title atoms and molecules. Before going to enter the chapter, some questions are given regarding to 6th is matter around us pure chapter. So some questions are given related to that chapter, we will answer and then we will start the lesson. See here, question, first question: does the weight of iron rod increase or decrease on rusting? So we studied about a rusting process in the last chapter. Okay, so does the weight of iron rod increase or decrease on rusting? So on rusting, the weight of iron decreases. Rusting nothing but iron reacts with oxygen and water percentage in the atmosphere. Okay, so iron form iron oxide, which degrade the weight of the iron. So on rusting, the weight of iron decreases. Yes, decreases. Then after see, where does the matter of charcoal go? Okay, on burning charcoal, it forms ash, isn't it? So while burning, it changes, it converts into ash, and that can be dissolved in soil. Some water mixed with gases and some of ashes dissolve in the soil. So that is the thing which happen while burning of charcoal. Where does the matter of charcoal go? It goes into soil. Okay, so wet cloths dry after some time. Where does the water go? Wet cloths, while if we for drying process, we'll keep the wet cloths on sunlight. So after some time, the water which is present in wet cloths escapes from that cloth. isn't it? By the evaporation process, we studied in the last chapter. By the evaporation process, the water which is present in the cloths evaporated. Okay, so wet clothes dry after some time. Where does the water go? Water undergoes evaporation process. Okay, undergo evaporation process. Then see what happens to magnesium on burning it in air. Burning of magnesium. Burning of magnesium produces dazzling white flames with a white ash. White ash. It changes into ash. Okay, what happens to magnesium on burning it in air? So while burning magnesium ribbon, it changes, it converts into ash, white ash with a forming a dazzling white fumes. What happens to sulfur? What happens to sulfur on burning it in air? So burning of sulfur produces certain gas which is called as sulfur dioxide. Burning of sulfur produces certain gases, releases certain gases called as sulfur dioxide. Or the weights of the reactants and products the same or different? So here all the questions explained that somewhat changes in the reactants. I mean what we took at the first to do activity, to do that thing, somewhat changes. See here, does the weight of iron decreases on rusting? The weight of iron decreases. Okay, so iron decreases, the weight of iron decreases. While where does the matter of charcoal go? Here charcoal converted into certain ash and which dissolve in soil. Wet clothes dry after some time. Here water evaporates. What happens to magnesium? Magnesium turns into magnesium oxide by forming a white dazzling white fumes, and ash is formed in that reaction. So sulfur reacts with oxygen to form sulfur dioxide. So here the original substance somewhat changes. Original substance somewhat changes. If the original substance somewhat changed, means a chemical reaction occurs. Okay, so the contents, the molecules, the substances which took at the first are called as reactants, and the substances which produced after the reaction is called as product. So one question is given, are the weights of the reactants and products the same or different? So by burning of magnesium ribbon, while if you weigh the magnesium ribbon and after burning if you weigh the ash, then both will be similar, both will be same. So burning of magnesium ribbon changes into ash, isn't it? So here the ribbon converted into ash. The weight of ribbon is equal to the weight of ash. Weight of ribbon should equal to the weight of ash. So here are weights of the reactants and products the same or different. So weights of reactants and products are same, right? So if you observe, scientist Antoine Lavoisier, so French nobleman, he made many important contributions to chemistry, and some call him as the father of modern chemistry. Very important. Who is the father of modern chemistry? Antoine Lavoisier called as the father of modern chemistry. Okay, so Lavoisier studied combustion reaction, nothing but burning in the presence of oxygen. So combustion reaction in detail. He was able to find the masses of reactants and products accurately irrespective of their physical states. Okay, so accurately he was able to find the masses of reactants and products. So based on his observations, he proposed law of conservation of mass. So this is the theory which we have to study in this chapter. okay, which are going to study that concept, law of conservation of mass, so which was explained by Antony Lavoisier. Okay, very important. Father of, he was called as father of modern chemistry. Okay, so these are some questions given in textbook, and see. So one lab activity given. So before that, in this chapter we are going to discuss certain concepts based on the terms atoms, molecules, compounds. So these are the terms which we can see in this chapter. So, and we are going to define these terms in this chapter. Okay, so let me see. One activity is given to prove law of conservation of mass, so which explained by Antony Lavoisier, just now we seen. So one activity is given, see, very important it is for the examination point of view, it is very important. And to find out the change in the mass before, after chemical reaction. So Antony Lavoisier calculated the weight of the atomic weight of the products and atomic weight of the reactants. Okay, so here that activity is given to prove that change in the mass, find out the change in the mass before and after chemical reaction. Okay, so is there any change in the mass before and after the reaction? For that we need some materials. What are the materials? See, lead nitrate solution from the laboratory, and potassium iodide, okay, which can be either solution form or solid form. So if there are solid, then we have to make it into solution. And distilled water, 2 conical flasks. So this is what conical flask, spring balance to weigh the reactants and products, small test tube, retort stand, rubber cork, thread, etc. So these are the materials required to do this activity. And procedure, see, at first we need to prepare solutions, isn't it? So prepare a solution of lead nitrate by 2 grams of lead nitrate in 100 ml distilled water. 100 ml distilled water in a 250 ml conical flask. Okay, so this is conical flask, whose limit is 250 ml. Okay, so within that pour 100 ml of distilled water. The capacity of this conical flask is 250 ml. So take 2 grams of lead nitrate in 100 ml distilled water. So this is the composition of lead nitrate plus 100 ml distilled water. 2 grams of lead nitrate and 100 ml of distilled water, pour in a 250 ml of conical flask. Prepare a potassium iodide solution by 2 grams of potassium iodide in 100 ml water in another conical flask. Take one more conical flask, and within that pour 100 ml water, which is mixed with 2 grams of potassium iodide. Potassium iodide, 2 grams of potassium iodide. So here the two solutions are made. So one is 2 grams of lead nitrate in 100 ml of distilled water, which is in 250 ml of conical flask. So with one more 250 ml conical flask, pour 100 ml within 2 grams of potassium iodide. So that is a lead nitrate solution, and this is potassium iodide solution. See, take 4 ml solution of potassium iodide from 100 ml solution. Take 4 ml in a small test tube. Okay, so from this conical flask, take 4 ml of potassium iodide solution in a test tube. Okay, so this contain potassium iodide solution. How much it is? 4 ml quantity. So just 4 ml. Within 100 ml, just take 4 ml. From the prepared solution, hang the test tube. Okay, hang the test tube containing 4 ml potassium iodide solution in the conical flask which contain lead nitrate solution. We already prepared 100 ml of lead nitrate solution, no? So within that, hang 4 ml which was taken in test tube. Okay, hang that test tube in the conical flask of lead nitrate solution. So which you can observe from the diagram, right? So hang the test tube containing 4 ml of potassium iodide solution in the conical flask containing lead nitrate solution carefully without mixing the solution. So should concentrate the test tube which should not be dissolved within the 100 ml solution. Okay, so do not mix, such that you should arrange, you should tie that test tube. So close the flask with a cork. So cork it to the conical flask. Okay, so now weight, this is what? Weight the conical flask by using spring balance, Okay, so note it down. Weigh the conical flask at first, then after weighing, now tilt and swirl the flask so that the two solutions mix. So just just tilt or swirl the conical flask so that the 4 ml of potassium iodide should be react with a 100 ml of lead nitrate solution. So for that, just fill the conical flask, the two solutions will be mixed. Weigh the flask again using the spring balance after the two solutions reacted. Okay, after reacting, just weigh the conical flask. Record your observation, weigh the flask and contents before mixing. So what it let W1, weight of the conical flask before reacts. So weigh the flask of content after mixing. So let it W2. Okay, so W1, W2. What do you observe? So by this activity we can observe that the two solution, the weight of the conical flask before reacting, after reacting remains same. So the reaction occur within the conical flask only. So no other substances added during the reaction, isn't it? So we weighed the conical flask after cork it. Okay, so we weighed the same conical flask after reaction. Just no other substance entered into that conical flask and no other substances added within the reaction, isn't it? So just the components which reacted within that conical flask. So here he concluded that a chemical reaction takes place and the mass remains same before and after the chemical reaction. So therefore mass is neither created nor destroyed in a chemical reaction. Mass neither created nor destroyed, isn't it? So we did not create anything within the reaction. Okay, so this is the conclusion. Mass is neither created nor destroyed in a chemical reaction. So this was explained by Anthony Lavoisier. See.
Add-on solutions. Add-on design.